Let's look at some simple examples of the basic properties of probability. So let's say we're rolling a fair six-sided die. So our sample space is the numbers 1 through 6, including 4. And let's define events, that is, subsets of the sample space. Let's let A be 1, 2, 3. Let's let B be 1, 3, 5. And let's define a third one, C, to be everything except for 1 and 6. So 2, 3, 4, 5. So the first property we talked about says that, oh, actually, let me define the probability here. So for a subset U of S, we'll define the probability of U to be the number of elements in U over the number of elements in S. So property 1 says that the probability of any event U is somewhere between 0 and 1. So for example, we have probability of A is 3 over 6, 3 elements over the total 6 in S, which is 1/2, and 1/2 is between 0 and 1. Same thing for B. Probability of C is 4/6, 4 elements over 6 elements, and that's 2/3, and 2/3 is between 0 and 1. And property 2 says that the probability of S is 1. Well, in our example, the probability of S is number of elements in S over number of elements S, which is 6 over 6, which is 1. So that works too. All right, now the third property is maybe more interesting than these. And that says that the probability of, if we have two different sets, A and B, the probability of A union B equals probability of A plus probability of B minus probability of A intersect B. Again, I'll just write that AB without the intersect sign. So in our example, let's use this A and that B. So probability of A union B is, let's see, in A union B we've got 1, 2, 3, and 5. So that's 4/6. And then if we look at the right hand side of the equation, probability of A plus probability of B plus, minus probability of A intersect B equals 1/2, 3 over 6 plus 1/2, 3 over 6, minus the probability of A intersect B. So 1 is in both of these and 3 is in both of these. So minus 2/6. So that's the number of elements in the set 1, 3 over 6, 2/6. And that is 1 minus 2/6, which is 6/6 minus 2/6, which is 4/6. So that matches what we had on the left-hand side. Property 4 is another very, very simple one. That says that the probability of U complement is 1 minus probability of U. So in our example, probability of A complement is number of elements in 4, 5, 6 over 6, which is 1/2, and 1 minus probability of A is 1 minus 1/2, which is also 1/2. So those match. Same thing for B. Maybe C would be slightly more interesting. The probability of C complement is the number of elements in the set 1/6 over 6. The only things that are missing from C are 1 and 6. So that's 2/6 and 1 minus probability of C is 1 minus 4/6. 4/6 because there's 4 things in C and 6 in S. So that's 2/6. And property 5 is a little bit more involved again. That's the inclusion-exclusion formula. So we're going to need A, B, and C here. So the probability of A union B union C equals probability of A plus probability of B plus probability of C minus probability of A and B minus probability of A and C minus probability of B and C plus probability of A, B, and C simultaneously. So in the example, the left-hand side is probability of A union B union C. So let's see what we have. We have 1, 2, 3, 4, 5. So it looks like we have everything in the union here except for 6. 1, 2, 3, 4, 5 over 6. So that's 5, 6. And the right-hand side is probability of A plus probability of B plus probability of C is 3, 6 plus 3, 6 plus 4, 6. Minus probability of A intersect B. A intersect B has 2 elements, 1 and 3. Minus probability of A intersect C. A and C have 2 and 3, 2 elements in common again. 2 out of 6. 2 and 3, specifically. Minus probability of BC. B and C have in common not 1, not 2, 3, and 5. So again, 2, 6, because they have 3 and 5 in common. Plus the probability of A, B, and C. So what do all of these sets have in common? Not 1, not 2, 3, not 4, not 5, not 6. So just 3. 1, 6 because of the 3. Alright, what happens when we combine all these fractions? 3, 6 and 3, 6 is 1. That's 6, 6 here. And then minus 2, 6, minus 2, 6, minus 2, 6 is minus 1. So we've got 1 and minus 1 cancel out, leaving us with 4, 6 plus 1, 6, which is 5, 6. Which is good because on the left-hand side we had 5, 6. The end.